You're facing a 3-phase to ground fault in a 4000-volt cable that stretches over 600 meters, and you want to pinpoint the fault without extensive excavation. Here's how you can approach this using calculations and specialized equipment. First, consider calculation-based methods. The Murray loop test is one option. This test measures the loop resistance of the cable. You compare this measurement to the known resistance per kilometer of the cable. The difference in resistance helps you estimate the fault's location along the cable's length. The standing wave ratio, or SWR method, is another calculation-based approach. It utilizes a signal generator and an SWR meter to assess the cable's impedance. The location of the fault is indicated where the impedance significantly deviates from its normal value. Now let's explore technology-driven solutions. Time domain reflectometry, or TDR, is a widely used method. A TDR device sends a high-voltage pulse down the cable. It then analyzes any reflected waves. The fault location is determined by measuring the time delay between the sent pulse and the reflected pulse. This delay directly correlates to the distance to the fault. An arc fault pinpointer offers a different approach. This device detects the presence of arcing within the cable. It uses sensors clamped around the cable to identify arcing activity, providing an indication of the fault's proximity. An acoustic fault pinpointer is another technology. This device measures the sound waves that are generated by the arc fault. It employs algorithms to estimate the distance to the fault based on these sound waves. Finally, distributed temperature sensing, or DTS systems, provide another method. These systems use fiber optic cables to monitor the temperature profile along the cable's entire length. A sudden and localized increase in temperature can pinpoint the location of the fault. Here's a recommended procedure for fault location. 1. Identify the fault type. Determine if the fault is a phase to ground fault or a short circuit between phases. 2. Use calculations or equipment. Apply one of the methods described, such as the Murray loop test, TDR, or acoustic pinpointer, to estimate the fault's approximate location. 3. Excavate at the indicated location. Carefully excavate the cable at the suspected fault location. 4. Repair the fault. Once exposed, identify and repair the damaged section of the cable. 5. Test and verify. After the repair, perform thorough electrical tests to verify that the fault has been successfully resolved. Remember that when using any of these methods, especially those involving high voltage, it's crucial to consult with experienced electrical professionals and follow the manufacturer's recommendations for accurate and safe operation. These technologies and procedures will allow you to identify the exact location of the fault so that you don't have to excavate the entire 600 meters.